Hello, my name is Natalie Calvert, and this is Physics 2, Lab 2, Lines of Charge. The introduction and purpose of this lab was to compare point charge models to the lines of charge model. We divided each part into segments, calculating those individually as point charges to calculate a more accurate charge for each tape. We also created multiple arrows to show the electric fields on each point and then added that up to the final net force. The fundamentals in this lab are using the process of superposition to add up all the segments, using Newton's second law and Coulomb's law to calculate the charge on the tape, and using tape to model lines of charge. For our assumptions, we assumed that each U-tape created had the same net charge. We treated each tape as if all the charge were evenly distributed along the model. Air resistance was also negligible. Takeaway: for the computational portion of this lab and model, we did not model the pieces of tape as point charges. We instead modeled them as lines of charge to get a better answer. For the equations of this lab, we used Newton's second law, the electric field equation, the electric force equation, which is Coulomb's law. Then we also came up with an equation to get the charge on the whole line of the piece of tape. And here are our constants. Some were given and some were found during the experiment. These procedures are just like Lab 1, where we had pieces of charged tapes and we had to see how they reacted to other pieces of charged tapes, neutral objects, and negatively charged objects. The results are that the charge of the tape was positive and attracted to the negative pin, repelled other tapes, and attracted to neutral objects. We need to keep in mind that tape B is a system, tape A and everything else are the surroundings. With the second experiment, we are now able to calculate the electric forces on each other and use the fact that the gravitational force and electric force will be equal and opposite, as seen in the free body diagram. These calculations were very similar to Lab 1, as we found the gravitational force, the charge, the deficient number of electrons, the number of atoms, the electrons per atoms, and then we found the electric force on the right. We also found an equation to calculate the amount of charge on the entire piece of tape as a line of charge instead of just a point charge. So here's the code I used to model the tapes as lines of charge. First, we begin with our constants and the electric field function that we also created in Lab 1. And then we were given a starter function to create the line of charge on the tapes. And then we also created top tape and bottom tape, and we were able to use the distance that we found between the tapes and the tape length as well. And then we were also given the function that calculated the electric field and the electric force on both of them, and we edited it and scaled it to make sure that the code ran smoothly as well. And then below, we created the electric force and the gravitational force arrows from the numbers that we calculated in the code, and we also scaled them, and these scaling numbers were found by trial and error to make sure that the code looked good in the running function. As you can see, here the code is ran, and the forces are opposite and almost equal in magnitude when treating the tapes as lines of charge. This electric force value varies drastically from when we treat it as a point charge. The magnitude of charge on one piece of tape that we found ended up being 2.1417 times 10 to the negative 8 coulombs, and the electric force was almost equal to gravitational force, as you can see. And we chose to create n equals 25 arrows for the electric field equation in the for loop that we had in our code from before, and this is our final model as the two pieces of tape as lines of charge. For the comparison from Lab 1, for my single point charge model, the charge was 9.41 times 10 to the negative 9 coulombs compared to my newer model, which gave us 2.14 times 10 to the negative 8 coulombs, which is much more specific. This lab was also more accurate because it was broken into segments and then added up, but it's not nearly perfect because we cannot do infinitely number of electric field arrows in the code computation. Sources of error: my computer computations could be slightly wrong. I could have calculated my Q value incorrectly, possibly, and the charges on each piece of tape may be unequal, unlike how we designed it. So what if you had modeled each of your tapes as a single point charge like in the previous lab? So we would have seen the gravitational force and the electric force would not have been equal at all if we modeled it as a single point charge, and that is why this time we modeled it as a line charge instead, and our two values, like you saw on the last slide, were drastically different as well. So why do these estimates differ? Which value is more likely to be closer to the real value, and why? These values differ because of the way we calculated our charge values for the line charge compared to the point charge value. The one that will be closer to the real value is for sure the line of charge value, because this one is more accurate because we split it up into segments and then calculated them individually that way. In conclusion, using the system as lines of charge and not point charges helps for a better overall solution experiment. Objects can again lose or gain charge very easily just by rubbing or touching as shown in the procedures. Using computational data can help you have a deeper level of understanding and helps you picture the experiment in real time. Thank you!